This video is going to talk you through solving polynomial equations. The directions on your notes say solve the equation. So the goal here is to get a value for x. And we know that exponents have an inverse function, and we could take the root that corresponds with that exponent to get x by itself. So that's what we're going to do. Our original problem is x to the fifth equals 32. And so to get rid of that x to the fifth, we're going to take the fifth root on both sides. So we will have x on the left, and the fifth root of 32, if we type that into our calculator, is 2. So now we're looking at example B. We've got a similar problem. The problem that we're given is x to the third, and it is equal to 125. Again, the exponent is 3, so we're going to take the third root of both sides so that we can get rid of that exponent. So the third root of x to the third is x, and the third root of 125 is 5. So x would equal 5. So this example is pretty similar to what we've seen so far. This is x to the fourth equals 1296. And so to undo x to the fourth, we're going to take the fourth root on both sides so that we can get x equals, and the fourth root of 1296 is 6. The next example in front of us, we've got 6x to the third equals 384. And so before we can do anything, we're going to have to divide both sides by 6 because we're trying to get x to the third by itself. So in order to get x to the third by itself, we've got to divide by 6. We get x to the third equals 64. So then same thing as the first three examples, we're going to take the third root of x to the third and the third root of 64. And so we're looking for the number that multiplies by itself 3 times to give us 64, and that number is 4. So x would equal 4. The next example we're going to look at is E, and the original problem is 3x to the third plus 5 equals 2192. So we're trying to get x to the third by itself, so we're going to treat this like its own variable, just as a regular x, and we're going to undo everything around it with the exponent being last. So the first thing we're going to do is move the 5. So we're going to subtract 5 from both sides. When we subtract 5, we get 3x to the third equals 2187. So then the next thing we would want to do if we were trying to get x to the third by itself would be divide by 3 on both sides. So then x to the third equals 729. And finally, to undo the exponent, we're going to take the third root on both sides. And the third root of 729 is 9. This one's pretty similar, not quite as many steps. The first thing that we're going to do, we've got this x to the 6th that we're trying to get everything else away from. So we're going to add 10 to both sides. So we've got x to the 6th equals 729. Now we have to figure out which root we need. So when we are looking at the exponent, we've got x to the 6th equals 729. We're going to need the 6th root in order to make that be x, which is what we are trying to find. So we are going to take the 6th root of 729, which in your calculator, if you take the 6th root of 729, you get that x is equal to, x is equal to 3. So G is going to start our last type of problem, and we've got x minus 1 in parentheses raised to the 5th is equal to 1024. So we've got to undo that exponent. There's nothing else attached outside the exponent. So we can start with the 5th root of x minus 1 to the 5th. And since we did it to one side, we've got to do it to the other, so the 5th root of 1024. When we take the 5th root of the left, we have x minus 1. You can write it in parentheses, or you don't need to write it in parentheses because there's nothing else attached. So we can just leave it as x minus 1. And then the fifth root of 1024 is 4. So now we're trying to get x by itself. The only thing we have left to do to get it by itself is add 1 to both sides. So our final answer would be x equals 5. This one again is very similar to G. Now the exponent outside the parentheses is 4. So instead of doing the fifth root, this time we're going to do the fourth root of what's in the parentheses, which is x plus 5 to the fourth. And then what we did on the left, we have to do on the right. So we're going to do the fourth root of 16. So the fourth root of something to the fourth power will cancel. So then we get x plus 5 equals, and in our calculator we can take the fourth root of 16, and that's 2. Now to get x by itself, we're going to subtract 5 from both sides. So 2 minus 5 is negative 3. Now the last example for this notes video is I, and the exponent is to the third. So we're going to take the third root of x minus 2 cubed. And so when we take the third root on the left, we've got to take the third root on the right. And since that's a negative number, it's okay to take the cubed root there, only because this index is odd. If it was even, we'd have to use I. And so now we have x minus 2 equals the third root of negative 14. And our goal is to get the x by itself. So to get x by itself, we're going to add 2 to both sides. So our final answer would be x equals 2 plus the cubed root of negative 14. Now, that's going to give you a decimal. So sometimes it'll say decimal answers are okay. If it tells you to leave it in simplest radical form, you're going to leave it just like this. If it says decimal answers are okay, you can use your calculator, and that's going to be negative 0.41 would be your final answer if you're told that decimals are okay.